Think those huge nuclear plant towers are just giant chimneys belching smoke and radiation? Think again, these towering structures, often seen looming over the landscape, are actually marvels of engineering designed to keep the environment safe and the plant running efficiently. Let's dive into the fascinating world of cooling towers and debunk some common myths. First myth to bust: those towers aren't chimneys, they're cooling towers. And guess what? They're not even unique to nuclear plants. You'll find them at coal plants, natural gas plants, and even some large industrial facilities. These towers play a crucial role in managing the heat produced during power generation. So what exactly do these cooling towers do? It's all about getting rid of excess heat. When a power plant generates electricity, it also produces a lot of heat. In fact, only about a third of the energy from nuclear power goes to electricity. The rest, pure, unadulterated heat. This heat needs to be managed effectively to keep the plant running smoothly and safely. Cooling towers handle that heat with a process called evaporative cooling. Here's the scoop. Hot water from the plant goes to the top of the tower and gets sprayed down like artificial rain. As the water falls, it evaporates, taking heat with it. Cool air rushes in from the bottom, and the warm, moist air rises and exits as, wait for it, harmless water vapor. Not smoke, not radiation, just steam. But why are these towers so massive? There are two main reasons. First, the volume of water. We're talking Olympic pool levels of water being processed every few minutes. A narrow tower just wouldn't cut it. Second, the hyperboloid shape, think giant hourglass, helps with airflow. Cool air in, warm air up and out. No fans, no extra energy, just physics doing its thing. Let's take a closer look at the design. The hyperboloid shape is not just for aesthetics. It's a brilliant design choice that maximizes efficiency. The wide base allows for a large volume of water to be processed, while the narrow top helps to accelerate the airflow, enhancing the cooling effect. This design is so effective that it's used in various types of power plants, not just nuclear ones. Now, you might be wondering about those white plumes you see rising from the towers. Are they dangerous? Absolutely not. Those plumes are simply water vapor. It's the same kind of steam you see coming out of a kettle at home. There's nothing radioactive or harmful about it. In fact, the cooling process is a closed system, meaning the water used in the towers doesn't come into contact with any radioactive materials. The sheer size of these towers also helps to disperse the water vapor over a large area, minimizing any potential impact on the local environment. This is particularly important for nuclear plants where safety and environmental protection are top priorities. The design and operation of these towers are subject to strict regulations and constant monitoring to ensure they function safely and efficiently. Inside the plant, the process is meticulously controlled. Operators monitor the temperature, pressure, and flow of water to ensure everything is running smoothly. Any deviation from the norm is quickly addressed to prevent any issues. This level of control and precision is what makes nuclear power one of the safest and most reliable sources of energy. The machinery inside a nuclear plant is designed to handle extreme conditions. The reactors, turbines, and cooling systems are all built to withstand high temperatures and pressures. This robust design is crucial for maintaining the integrity of the plant and ensuring the safety of the surrounding area. The cooling towers play a vital role in this system. By efficiently removing excess heat, they help to maintain the optimal operating conditions for the plant. This not only ensures the plant runs efficiently, but also extends the lifespan of the equipment, reducing the need for costly repairs and maintenance. The process of moving hot water to the top of the tower and spraying it down is a continuous cycle. The water is collected at the bottom, cooled, and then pumped back into the system to absorb more heat. This cycle repeats over and over, providing a constant means of heat removal. The spraying mechanism at the top of the tower is designed to maximize the surface area of the water droplets. This increases the rate of evaporation, making the cooling process more efficient. The design of the nozzles and the distribution pattern of the water are carefully engineered to achieve this effect. At the base of the tower, large air intake vents allow cool air to flow in. This air is drawn in naturally by the temperature difference between the inside and outside of the tower. As the cool air rises through the tower, it absorbs heat from the falling water droplets, becoming warm and moist. As the water droplets fall, they lose heat and cool down. This cooled water is then collected at the bottom of the tower and pumped back into the plant to absorb more heat. The warm, moist air rises to the top of the tower and is released as water vapor. The release of water vapor at the top of the tower is a key part of the cooling process. This vapor is harmless and quickly disperses into the atmosphere. It's a natural and efficient way to manage the heat produced by the plant. So, the next time you see those massive towers, don't freak out. They're not spewing smoke or radiation. They're engineering marvels, cooling down the plant and keeping everything safe. Pretty cool, huh? The design and operation of cooling towers are a testament to human ingenuity. They represent a perfect blend of science, engineering, and environmental stewardship. By understanding how they work, we can appreciate the role they play in providing us with clean, reliable energy. The sheer volume of water processed by these towers is staggering. Imagine an Olympic-sized swimming pool. Now imagine that amount of water being cycled through the tower every few minutes. That's the scale we're talking about. This massive volume is necessary to handle the heat produced by the plant. A narrow tower simply wouldn't be able to handle the volume of water or the heat load. The wide base of the tower allows for a large surface area for the water to be sprayed and cooled. This design is crucial for the efficiency of the cooling process. The hyperboloid shape of the tower is another key design feature. This shape creates a natural draft, drawing cool air in at the base and expelling warm air at the top. It's a simple yet effective way to enhance the cooling process without the need for additional energy. The natural draft created by the hyperboloid shape is a perfect example of how physics can be harnessed to solve engineering challenges. By understanding the principles of airflow and heat transfer, engineers have created a system that is both efficient and sustainable. One of the most impressive aspects of cooling towers is that they operate without fans. The natural draft created by the shape of the tower is sufficient to move the air through the system. This means there's no need for additional energy to power fans, making the process more efficient and environmentally friendly. And those white plumes you see rising from the towers, they're totally non-radioactive. It's literally just steam, like your kettle at home. This steam is a byproduct of the cooling process and poses no threat to the environment or public health. The comparison to a household kettle is quite apartment. Just as the steam from your kettle is harmless, so too is the steam from the cooling towers. It's a natural part of the process and a testament to the efficiency of the design. So next time you see those massive towers, don't freak out. They're not spewing smoke or radiation. They're engineering marvels, cooling down the plant and keeping everything safe. Pretty cool, huh? Next time you see those massive towers, remember the incredible engineering that goes into them. They're not just structures, they're vital components of our energy infrastructure, working tirelessly to keep our power plants running smoothly and safely. Pretty cool, huh?